Good morning, my dear students. In last problem, we are keeping A is fixed. We are taking into account translation as well as scaling. Now in this pentagon, we are taking into three activities into account. All the three transformation into account. One is scaling, translation, as well as rotation. So in that we will consider this is very important problem, which can perform all the activities of all transformations. So let us consider a pentagon ABCDE where A equal to 2 comma 1, B equal to 6 comma 1, C equal to 7 comma 4, D equal to 3 comma 8, and E equal to 1 comma 4. Is scaled thrice in x direction and twice in y direction. Pentagon is also rotated about point A at an angle of 90 degrees clockwise. Find the coordinates of transformed pentagon and draw the pentagon. So here you can see that this A, B, C, D, E, and this A is fixed. We have to rotate this A about this point A, about z-axis, clockwise direction. So generally B comes here. Okay, but we don't know what are the coordinates of other coordinates. We cannot find out manually or by paper and pen. Only thing that we have to use this matrix multiplication, and best way to write that, use these matrices in C programs and find out that transform coordinates. That same program can be written as a background of CAD development. Now let us first will take into account translation matrix, because A is fixed. First we have to move A is into origin. For that, moving A to the origin, since A is fixed, we'll get the translation transformation matrix T1 as 1 0 0 0 1 0 minus 2 minus 1 minus 1 1, where 2 units x direction it has to travel in the negative x direction. Similarly, 1 unit it has to move in negative y direction. That's a minus 2 minus 1. Then second activity is scaling transformation matrix. Thrice in x direction, twice in y direction. This becomes as 3 0 0 0 2 0 2 0 0 0 1. And third activity is rotating the pentagon at an angle of 90 degrees clockwise. So for this we have that cos 90 minus sin 90 is 0, sin 90 cos 90 is 0, 0 0 1. This is the formula we have discussed in the earlier lectures. So here cos 90 becomes as 0 and sin 90 becomes as minus sin 90 becomes as minus 1. This is 0, sin 90 becomes as 1, cos 90 becomes as 0, and 0 0 0 1. Then fourth activity, since A is at now origin, we have to move again A from origin to the original location. Again, we have to add the 2 units in x direction and 1 unit in y direction. Then translation transformation matrix T2 becomes as 1 0 0 0 1 0 2 1 1. These are the four transformation matrix T1 S or T2. We have to take into account four transformation matrix. We have to multiply all these three to get the concordation matrix, as we have done the last problem. So now it becomes as concordation matrix C. It is called as combined matrix C double dash equal to T1 S or T2. So take into matrix multiplication of these four matrices. First you multiply these two matrices, then you multiply the other two matrices. Result of this again multiply with the result of these two. Then we'll get the one matrix 3 by 3. That is nothing but 0 minus 3 0 2 0 0 0 7 0 7 and 1. To cross check this combined matrices whether it's correct or not, we have one clue is there, that is A is fixed. So A dash equal to A into C. So first you multiply A dash with the concordation matrix A. You multiply A with the concordation matrix to get A dash. Whether A is A dash should be equal to A. Then only your combined matrix C is correct. Let us find out this 2 1 1 0 minus 3 0 2 0 0 and 0 7 1. Then we get again 2 1 1 1. It means A is fixed. A is fixed because A dash equal to A. Hence C concordation matrix C is correct. So we confirm from this that concordation C is correct. We can find out other transform matrix. In that case, B dash equal to B into C double dash will get as 2 11 1, and C dash equal to C into C double dash, that is nothing but 8 minus 14 1, and D dash equal to D into C double dash 16 minus 2 1. E dash equal to E into C double dash 8 4 1. Go back to this will get as, if you draw this transform rectangle with the found coordinates, we'll get this blue color pentagon, because this is double the size, in x, thrice the size in x direction, twice the size in y direction, and it is a is fixed and it is rotated about the clockwise about the dead axis 90 degrees. So these are the transformation matrix. So using this matrix multiplication, we can conclude this, use this transformation matrix for the scaling, translation, rotation, and write down the programs. Use those programs for the background of the CAD software development. So that's why transformation is one of the functions of the graphic software. We need not to. It is already it is already built. Software, the software with the C program already is there in the background of CAD development, CAD software. So once you click the button, as mentioned, this if you want 90 degrees, automatically this transformed pentagon will be there on the screen. So we need not to do anything, because background is already, this kind of software is already written by CAD software developers. With this, we'll end up with the unit 1, where we have learned about that product cycle, design process, integration of CAD CAM to the product cycle, application of CAD to the design process, CAD hardware and CAD software, and transformation, mainly important transformations. Now let us go into the unit 2, where geometry modeling, in the next class. Thank you, one and all.